Here I will show how to use single particle profiler as a program for standard fluorescence correlation spectroscopy analysis, and how to get the files, how to fit the correlation curves, how to export, how to see the diffusion coefficients. So first of all, I will import some data. Data comes from here. So here I have the calibration file and also the file where the data from molecule diffusion in the synthetic lipid bilayers is stored. So here, for example, I have the calibration file. I have it also in two colors. So here I have Alexa 488 and Alexa 647. And here I have different data files. So this is the Abberior-Star-Red diffusion in Giant Unilamellar Vesicles. And this is the far-red dye. So we are going to use the far-red probe for calibration as well. So you can go here first, diffusion analysis, and you go to calibration file. And we need to fit pretty much channel 1 and channel 2. Both cross-correlation channels here are useless because the dyes are not interacting and the correlation is pretty much 0. So I will disable them both over here. Here I will expand a little bit. And you see here the fitting parameters, and fitting parameters I will use the following. So first of all, offset is 1 over here because you see that they decrease to 1. Then Gen 0, that's actually what we also want to calculate. Then since we have only one population, this I will fix to 0. The amplitude, then this is normal free diffusion, so I will just set this to 1. Aspect ratio of the focal volume we actually want to well, determine. And then also I will fix here triplet relaxation time, which is 0.005 milliseconds or 5 microseconds for these organic dyes. Now you can just click fit over here and see that first curve is already fit. So you see that diffusion time is calculated and aspect ratio is pretty good over here. So if you want to fit everything over here, or you can fit just the second channel, right? So right now we fitted the first channel, now we want to fit the second channel. So the second channel is here, then you do again these things. And you see that, okay, alpha fix, this fixed, then you leave this aspect ratio released as well. So you click fit over here, and now this one is fit. So the fit is also pretty good. And here TXY is slower because Alexa 647, well, it's quite bigger. And we will need to know two things from this fit. First of all, our TXY, which is 0.059, and aspect ratio, which is 4.3, which is also pretty, well, standard aspect ratio for such type of experiment. So this we now remember, and now we are going to move to the next file over here, which is our sample. We are moving to the real samples. And here we have membrane 3, membrane 4, and so on. So these are different diffusion studies in the synthetic giant unilamellar vesicles. And here again we need to fit. So first of all, I will here go through and select all the files that I'm going to fit. And I go back to the file 1, and I need to set up everything over here. So first of all, it is important here, since we already did the calibration, first of all, to input here the diffusion time of the dye that we found, which was 0.059. And this is the field for the diffusion coefficient, which for Alexa 647 is 665 micrometers squared per second. And this diffusion coefficient is actually the same for all dies, but diffusion time can be different at different setups. So that's why we measured the calibration. And now when we will measure also diffusion time for our object in the membrane, we are going to use this diffusion coefficient in diffusion time as a reference to calculate diffusion coefficient from diffusion time that we are going to obtain here. Now I'm going again to set the parameters. So offset is 1, GN0 I leave varying, then amplitude is 1 as well. Diffusion time I leave here, alpha is 1. Aspect ratio, so here I would put in the aspect ratio 4.3 that we calculated before, but we are in the 2D, so I actually have to go back to 2D, and here I have to set up everything again. It is also important to note that when you move between files, everything here drops to default, unless your files are already processed. But it is important that when you launch Fitting, you again keep an eye on this table that you have right setup. So again, 2D, this is 1, this is 1, this is 1. You see aspect ratio disappeared because we are now in 2D. If you had some objects in 3D, then of course you move back to 3D and aspect ratio reappears. 5 microseconds diffusion, 5 microseconds triplet relaxation time stays over here, but it's important also for you to check which type of molecule you are actually studying, and then triplet relaxation time can be different. Okay, what's next? So now when this is pretty much done, then you can click Fit. And you see that diffusion time is calculated. And now we want to obtain diffusion times for everything pretty much. So we click here Fit ticked because calibration we don't need anymore. And now it has processed everything. So now this we can close. And now I would again export the data. The results. So now I select everything I want to export, and here I click Output. And then when the export is done, I go to the folder where my data is. So it was over here. Here again is the new folder with the analysis, and here is first of all the summary. Okay, there was an old workbook of the same name opened, so I closed it. Now I open it again. Yeah. So in principle, you can also study GP in that manner, but we didn't need that. So all GP related fields, sheets are actually empty here. Then you have for every channel, you have first diffusion times for every repetition and for every file. Then you have diffusion coefficients, and here you have also CPM, which I also very often need to identify what is going on with my molecular brightness. If you need other parameters, then also for every file you have a separate Excel document. So here, for example, you see for a file which is called membrane 3, and you see that fixed parameters are here: offset, amplitude, and alpha. And tau triplet is also there. Here you also have number of molecules, which might be interesting for you. So if you need more parameters, you can also consult these Excel files, and there you have all the results that you might need.